Hi everybody, we are working on area of regular polygons day 2. We'll start off with a couple of reminders here in a minute, but just a couple of notes. We're going to dig in a little bit today, so mentally prepare yourself, but you've got this. And also today will be the first day that your homework assignment is on CUDA Works. And so you should have signed up for that, and Mrs. Keyser, I accepted you, and once you log in, you should see that your assignment is there. So just be aware of that. So, all right, here we go. So area of a regular polygon, day 2. The first thing that we're going to start off with for some reminders are special right triangles, because we're going to use them today. So remember, we've got two types of special right triangles, the 45, 45, 90, which is also a right isosceles triangle. And remember that the sides have a relationship. The two legs, they're congruent. So if they're both length x, then the hypotenuse is the leg times the square root of 2. So you just simply take the leg length times root 2 to get the length of the hypotenuse. Or if you're given the hypotenuse, you take the hypotenuse and divide it by root 2. Okay? The other special right triangle was the 30, 60, 90. And you probably want to jot these down wherever you're taking notes if you don't remember them, because we're going to use them. They are the key to our success today. So if this is 60 degrees in here, and the short side is x, then the long leg is x times root 3, and the hypotenuse is x times 2, because remember, this is half of an equilateral triangle. All right, so those relationships are going to be very important as we work through these area problems today. Another reminder is that the area of a regular polygon is equal to half A times P. And A is the apothem, or the apothem, and P is the perimeter. All right, so that's everything that we're going to need. So let's go ahead and dig in on these. So, oh, never mind. I have some practice. I forgot about this. That's good. We have some practice of 30, 60, 90 triangles and 45, 45, 90 triangles. So I'll do the first two, and then you can check the other two to see if you've got them right. So in this case, in number 1, we are given the long leg. And so remember, the long leg and the short leg, if the short leg is y, then the long leg is that times root 3. So to go the opposite way, we're going to say that y is equal to 6 divided by root 3. And we'll need to rationalize that. So we'll multiply it by root 3 over root 3. And get that y is equal to 6 root 3 over 3. But 6 divided by 3 is 2. So it's 2 root 3 for y. For x, remember that that is the hypotenuse. It's opposite the 90-degree angle. So we're going to take our short leg, 2 root 3, and multiply it by 2. So 2 times 2 root 3 is the length of x. And 2 times 2 is 4 root 3s. So x is equal to 4 root 3 up here. So that's a 30, 60, 90. Number 2 is a 45, 45, 90. And so first we are given a leg, so it's pretty easy to say that V is also equal to 7 root 2 over 2. And then U, remember, is the hypotenuse. And to find the hypotenuse, we multiply the leg, 7 root 2 over 2, times root 2. Okay, now root 2 times root 2 is root 4. And the square root of 4 is 2. So 7 times 2 over 2, which is 14, and 14 divided by 2 is 7. Or we can just simplify out those factors. Okay, so u is equal to 7. All right, so go ahead and pause the video and try 3 and 4 real quick, and then I'm going to work through them real quick right here in the video rather than put a separate document up. So in this case, we've got the short leg. So y is equal to the short leg times root 3. And the hypotenuse is equal to the short leg times 2, which is 16. Over here in our 45, 45, 90, we're given the leg. So n is also equal to 9. And m is equal to the leg times root 2. Now, as we move through these problems, you'll see that you might have to move, be given a hypotenuse and move back to the leg. But that's why we have examples. Okay, so let's go ahead and take a look at some area examples. So our instructions say find the exact area of each regular polygon. Leave your answer in simplest form. So that means no rounding today. So everything is going to be simplest radical form. To find the area, hi Cooper, I'm recording right now. So my recording layer is not secure enough that they can't yell through the door. But anyway, so the area of a regular polygon, remember, is equal to 1/2 times the apothem times the perimeter. Now, if you go back to yesterday, finding the area of the regular polygons that we gave you is pretty straightforward because you were given both the apothem and the perimeter. Today, that's not the case. You're only given one piece of information, and you're going to have to work for the other piece. So when we start in number 5, we are given a side length. And so pretty easily, we can see that we want our apothem and our perimeter, so I'm just going to note those down here. We can see that, Cooper says hi again, that the perimeter is going to be 3 times 16 root 3. So 3 times 16 is 48 root 3. So there's our perimeter. That was straightforward. What is not as easy to work through, well, it's not difficult, but what we don't have explicitly is the apothem. So we need to solve for this apothem A. So here's where the central angles come into play. Okay, so yesterday we worked on central angles and you guys did a really nice job on your homework, so I think you've got it. But we want to find the central angle, the angle between the center and the 2 radii. Okay, so this is an equilateral triangle, so we've got, we would have 3 radii, which means to find that central angle, we're going to do 360 divided by 3. So one of these central angles right here is 120 degrees. Now, if we divide that, if we use the apothem to divide this triangle in half, okay, then we get that angle, ooh, things are getting tight, but right here is half of 120, so it's 60. So what I'm going to do is I'm going to redraw the right triangle with the apothem larger. So I've got the apothem here. This angle is now, this is 90, because an apothem is always perpendicular to the side. And this angle right here is 60. So always draw that right triangle because it's going to keep, it's going to make things easier. Now, this side length right here, okay, it's not 16 root 3 because remember this is half of that triangle, so it's now half of that whole length, which is 8 root 3. And now look what we have. We have a 30, 60, 90 triangle with one side, so we can solve for the apothem. If this is 8 root 3 and that's the long leg, then the apothem you divide by root 3 and you get that the apothem is equal to 8. So the apothem is equal to 8. Okay, so now we finally have our apothem, and we can find the area of this polygon. So the area is equal to half of the apothem, which was 8, times the perimeter 48 root 3. So half of 8 is 4, and 4 times 48 is 192, and times root 3 gives us our total area. So our area here is 192 root 3 square units. Okay, so that's 10 minutes. If you think that you've got this down, you can stop and work through a couple of these and then come back and check, or, you know, fast forward to the end of the video and check your answer. And there's only a handful of homework problems because they do take a little bit more time, but I'm going to go ahead and do at least one more, if not two, well, maybe all 4. So I'm going to erase this stuff and take a look at number 6. Okay, so remember our goal is 1/2 apothem times perimeter. So the apothem and the perimeter. All right, in number 6, we're actually not given the apothem or the perimeter, okay? So in this one, we are given the radius. So this length 10 right here, it goes from the center to a vertex, so that is a radius. So then this is going to also be 10 because it's a radius. And then we're going to find that central angle. So if there's 4 sides and there are 4 central angles, so 360 divided by 4 makes this 90 degrees. Well, look what we have. Now we have a 45, 45, 90. So what we can do is we know that if both legs are 10, we can multiply by root 2 to get that this side is root 2. Now we know it's a square, and the area of a square is side squared. So we could take 10 root 2 and just square that. And you would get, well, 10 squared is 100, and root 2 squared is 2, so you would get 200 square units. All right, but the purpose of this is to actually find the apothem, and so let's go ahead and still work through that, okay? So first, though, our perimeter, if one side is 10 root 2, then 4 sides would be 40 root 2, 4 times 10 root 2. And now we can take a look at the apothem. So draw that apothem in here. Okay, that should have just split your triangle. And I'm going to copy that right triangle off to the side. And that right triangle has the apothem. Half of my central angle, so this is now 45 degrees in here. Okay, and my hypotenuse for this one is the radius, and that's 10. So if that's the case, to go from hypotenuse back to the side, we're going to do 10 divided by root 2, and when we rationalize that, we get 10 root 2 over 2, which simplifies to 5 root 2. Running out of space. So our apothem is 5 root 2. So the area equals half of the apothem times the perimeter. All right, so we've got root 2 times root 2, which is 2. And 2 times 5 is 10. And half of 10 is 5. And 5 times 400, or 40 is 200. So that checks out and is the same as the other method. All right. Let's take a look at numbers 7 and 8. Okay, so in number 7, again, we are given the radius, and we need to find both the perimeter and the apothem. So first, let's I'm going to draw these down here. We know that those are both 12 root 3. This one is a hexagon. It has 6 sides, so it has 6 central angles. So 360 divided by 6 means that that central angle right there is 60 degrees. When we draw in our apothem and cut it in half, we want to look at just that right triangle. Okay, so here's our apothem. And then this, we cut that in half, so that's now 30 degrees. Okay, and then remember that we were given the radius. So the radius on the right triangle is right here. Ooh, that didn't work, but you got it. And that's 12 root 3. So now we have a 30, 60, 90 triangle, and we're going to solve for the missing sides to get the apothem. So to go from the hypotenuse to the short leg, you divide by 2. So 12 root 3's cut in half is 6 root 3's. To go from the short leg to the long leg, multiply by root 3. So 6 root 3 times root 3 is 6 times 3, which is 18. So we're going to use the apothem, which is 18. And then we've got this short side length, which is 6 root 3, which means that this whole side length is 12 root 3. And that makes sense because remember the radius is makes the hypotenuse of a 30, 60, 90, and that a 30, 60, 90 is half of an equilateral triangle. So our perimeter is 6 times 12 root 3. So 6 times 12 is 72, and we're going to go ahead and work through our area.
Mommy?
Guys, I'm still recording.
Emma wants to come in and talk to you for a few minutes.
I'll be out in a few minutes.
Mommy, let me tell you something. This nickel, the radio is telling us something. Well, I don't know.
I think they want nurses.
No, they don't.
All right, so there we go. The area is 648 root 3 square units for number 7. All right, let's see if we can work through number 8. All right, it's not like a smart board. I can't circle it and tap it. Okay, so remember that the goal here is area is equal to 1/2 apothem times perimeter. Those are the two parts that we need. The apothem is 16, and we are looking to find the perimeter. So we're going to draw on our radii, and we're going to find that central angle. So here's our 2 radii. This is 3 sides in this polygon, so 360 divided by 3 tells us that the central angle is 120 degrees. Okay, now remember our apothem cuts that isosceles triangle in half and cuts that central angle in half, and we're going to draw the right triangle with the apothem. This is the apothem, this is the radius, and this is half of the side. Okay, so hopefully you were able to follow what each part was. So it gives us an apothem of 16, and when we cut that 120 degree angle in half, it became 60 degrees. So now we've got a 30, 60, 90. So if we use our 30, 60, 90 rules, we've got the short side, the hypotenuse is equal to 32, which we actually don't even need, but that's okay. And the half of the side is equal to 16 root 3. Which means that one full side is going to be 16 root 3 times 2. So that's 32 root 3. So our perimeter is going to be one side times 3. 32 root 3 times 3 is 96 root 3. And now we can use the formula. The area is equal to half of 16 times 96 root 3. And for this one, we get 76 root 3. I'm sorry, 768 root 3 square units. All right, dig in. You've got this. We'll talk to you later. Bye.